Bismillahirrahmanirrahim. Assalamu alaikum. Dear all, first of all, a warm welcome to the class of CS352 Introduction to Soft Computing. In this class, I hope you will learn a lot about artificial intelligence and the soft computing techniques specifically related to AI. For those of you who want to make a career in data science or in AI, this is the perfect class to get to know the techniques that are used in AI, specifically from the point of view of data science and pattern classification. Warm welcome. So let us get started with this course in a soft manner, and let me introduce this course first to you in this lecture. I'll basically be introducing to you the course staff, the teachers, that is me and my team. I'll then be introducing to you the course textbook, and from where you can basically get the different reference books and different reference information that you might require, as well as the PDFs and the lecture slides if you need. Finally, I'll be talking about the course information. So before I start with this lecture in particular, I'll first go through the course breakdown, the way this course is going to be taught. The course is divided into different topics. I have identified close to 10 topics, and in each topic we will be discussing some salient features, some salient points, or some techniques related to AI and soft computing. And the purpose is the lectures will be divided into sections. So each lecture, each topic, so each of these 10 topics may have one or more sections. So for example, this particular lecture has only one section because this is just introduction, so I won't really go in depth into this particular topic. But otherwise, each of the topics is maybe divided into two or more lectures or sections. And in each section, I'll be focusing on just one main point. It will be easier for you to understand, as well as for me to deliver or divide the course into subsequent points, and hence it would be easier for all of us at the end of the day. Having said that, let us now begin formally with this lecture, and let us see how what we're going to see in this course and who we are, right? So let us just start with who we are in section 1, course staff. So let us start this course with introducing myself first. My name is Dr. Raja Hashim Ali. I am a PhD in computer science from KTH or Royal Institute of Technology or Kungliga Tekniska Högskolan in Stockholm, Sweden. And you can view my Google Scholar profile or my research profile on the Google Scholar using the username Raja Hashim Ali. I'm currently working as an assistant professor at GIK Institute, Topi, Pakistan, Ghulam Ishaq Institute, basically. And you can email me with respect to this course at hashim.ali@giki.edu.pk. Please remember to add CS352 to the subject. Oh, and by the way, I'm going to be teaching this course for the first time, so I'm going to experiment a lot in this course. But as you might see, the contents here and everything would be kind of very much up to date, and I'll try to do justice to this course as much as possible. My teaching assistant is Ms. Rida Saeed, and she's going to be assisting me for the second time. Her email is also given here, and you can contact her in case of any queries. The class hours for this online classes are Monday 10 to 12, where I'll basically be uploading the lectures. Then on Wednesday 10 to 12, I'll basically be conducting an interactive session with you guys, where we will be talking about the course in general, the contents in general, and maybe we can have a quiz as well during that time, or even have some sort of assessment, whatever is feasible or decided at a later time. So for now, we'll have two classes. In the first class, actually, I'll just be uploading the whole lectures, weekly lectures on the topic. which will take you some time to go through them, and then you can always come back to me on Wednesday with an interactive session. Thank you. So let us get started with this course in a soft manner, and let me introduce this course first to you in this lecture. I'll basically be introducing to you the course staff, the teachers, that is me and my team. I'll then be introducing to you the course textbook, and from where you can basically get the different reference books and different reference information that you might require, as well as the PDFs and the lecture slides if you need. Finally, I'll be talking about the course information. So before I start with this lecture in particular, I'll first go through the course breakdown, the way this course is going to be taught. The course is divided into different topics. I have identified close to 10 topics, and in each topic we will be discussing some salient features, some salient points, or some techniques related to AI and soft computing. And the purpose is the lectures will be divided into sections. So each lecture, each topic, so each of these 10 topics may have one or more sections. So for example, this particular lecture has only one section because this is just introduction, so I won't really go in depth into this particular topic. But otherwise, each of the topics is maybe divided into two or more lectures or sections. And in each section, I'll be focusing on just one main point. It will be easier for you to understand as well as for me to deliver or divide the course into subsequent points, and hence it would be easier for all of us at the end of the day. Having said that, let us now begin formally with this lecture, and let us see how what we're going to see in this course and who we are, right? So let us just start with who we are in section 1, course staff. So where will you be able to access the whole content and each and every lecture? What I've decided to do in this course is I've worked on putting some content on CMS, then our mode of interaction or lecture would be Microsoft Teams, and actually you can get the video lectures on YouTube. So I'll be using 3 systems simultaneously, and each system will have a specific job to be done. For example, the attendance of the whole class will be maintained in CMS and will be updated regularly. So what you need to do is you need to keep an eye on CMS system and report attendance issues immediately within 5 days of attendance update. After these 5 days, no queries regarding your attendance will be entertained beyond this point. Okay, so you need to keep in mind that the attendance, for keeping a look on attendance, you need to log into your CMS and keep an eye on your attendances. Secondly, for queries and for uploading the contents, I'll be using Microsoft Teams. All the lecture slides, additional reading materials, and other content will be uploaded on the course page on Microsoft Teams. In addition, all your queries related to the lectures and scheduling, including the interactive sections, will also be taken on Microsoft Teams. So the class on Wednesday will probably be held on Microsoft Teams, and that is some thing you need to remember, to be online at 10 on Wednesdays. Also, it is very much possible that I might be taking your assessments on the same Microsoft team or some other similar format, but at the moment we have not decided about your assessment. It will probably be on Microsoft Teams. Okay, then the third thing is, and the third content that I'll be using a lot more would be YouTube. So I'll make basically videos of all my lectures, and all the video lectures will then be posted on YouTube. The link will be posted on Microsoft Teams page or channel every week. The weekly lectures will be posted at most by Monday of every week, and interactive session will be held later on Wednesday probably, or even later in the same week. So that is the plan that we have currently at the moment, and all the content will be accessible to you either through CMS or through Microsoft Teams or YouTube. These are the 3 different channels that I'll be using throughout, and you need to keep an eye on all of them to get to know the updates. Of course, the main page here would be the Microsoft Teams page and channel course CS352, where I'll put on the YouTube links all the time, as well as the slides and other content, additional reading materials as well. But attendance will not be updated on Microsoft Teams. It will basically be posted on CMS through the normal way. So you need to keep an eye on it quite a lot. You all must be inquisitive about what textbook would I use for this course. Well, as shown here, I will not be using any textbook, or I will not be following any textbook. However, for references, we have 2 books that we'll be using. The name of the books are the first book that I'll be referring to, and actually this is a very standard textbook that has been used all over the world, is by Russell and Norvig, Artificial Intelligence, A Modern Approach. 4th edition is already available, and I'll be using this book for reference a couple of times. In fact, you're already studying using this book in your other course, CS351, Introduction to Artificial Intelligence. But as I and Dr. Said have decided together that we'll basically be dividing the contents into 2, and half the portion I will be teaching and the other half he'll be teaching. Having said that, I'll not be following this book in complete letter and spirit, but instead my PowerPoint lectures and slides might be enough for you guys. At the same time, another book that I would always recommend to you guys is Artificial Intelligence, Structures and Strategies for Complex Problem Solving by George F. Luger, 6th edition. And again, this is an excellent book that you can always use for reference on most of the topics, but the content will not be following these books. And here there's a warning for you guys as well, that since these are not the course textbooks, so our presentation does not necessarily follow the presentation in the book or even the order in the book. So let us get started with this course in a soft manner, and let me introduce this course first to you in this lecture. I'll basically be introducing to you the course staff, the teachers, that is me and my team. I'll then be introducing to you the course textbook, and from where you can basically get the different reference books and different reference information that you might require, as well as the PDFs and the lecture slides if you need. Finally, I'll be talking about the course information. So before I start with this lecture in particular, I'll first go through the course background, the way this course is going to be taught. The course is divided into different topics. I have identified close to 10 topics. And in each topic, we will be discussing some salient features, some salient points, or some techniques related to AI and soft computing. And the purpose is the lectures will be divided into sections. So each lecture, each topic, so each of these 10 topics may have 1 or more sections. So for example, this particular lecture has only 1 section because this is just introduction, so I won't really go in depth into this particular topic. But otherwise, each of the topics is maybe divided into 2 or more lectures or sections. And in each section, I'll be focusing on just one main point. It will be easier for you to understand, as well as for me to deliver or divide the course into subsequent points. And hence, it would be easier for all of us at the end of the day. Having said that, let us now begin formally with this lecture, and let us see how what we're going to see in this course and who we are, right? So let us just start with who we are in section 1, course staff. So let us talk about the course prerequisites and what expectations I have regarding your knowledge or information from your previous courses, and maybe what background you already have. that I'll be assuming you have, and then I'll basically be just not talking about the background stuff or the prereq stuff, and I'll just be moving on. So the first thing that I really want you guys to be or to know is that you should be comfortable in programming in some language, maybe C++ or Java or even Python for that matter. Although I understand that you're also studying Python in the CS352 351 lab, the Introduction to Artificial Intelligence lab, but you need to know a programming language really well before you start taking this course. Another prereq that is kind of assumed is that you must have some knowledge of algorithmic concepts, for example, running times or complexity, data structures, trees, sorting, searching, etc. And I believe since I have already taught to you guys discrete mathematics, so I feel that you must already be very comfortable in the algorithmic concepts that are necessary here, as well as you have also studied data structures from Dr. Zahid, I presume, and hence I believe that your data structures must also be quite up to the mark. Finally, another prereq that I feel is necessary for this course is the probability and statistics. You must have some kind of knowledge of basics of probability and stats to study this course. Okay, so let's talk about course evaluation. We have a few quizzes or in-class exercises that will count to 30% of your total marks towards your grade. Then we have got assignments which are worth 10% of your total marks towards your grade. Then we have got a midterm scheduled after 8 weeks of your semesters, where which will basically be 20% of the total weightage of your overall marks. And finally, after 15 weeks of lectures, when you study all the 10 topics, we'll hold the final exam in the 16th week, which will be worth 40% of the total, which will contribute 40% towards your total marks. After the course evaluation, we need to talk about the different policies that will be used during the course. Here are the three main policies. Of course, one is related to assignments. There will be in total 2 programming assignments that will be given to you. You can discuss it with me, with other students, and even take help from internet, but you must acknowledge the source at all times. But at the same time, the only restriction is the whole code as well as the design must be completely yours and implemented by you. Also, the due dates for assignments will be strict and there will be no leniency shown in terms of due dates. Kindly observe them. Secondly, we'll have a quiz policy in place where in fact you will have 15 in-class exercises. All the in-class exercises will be surprise and unannounced. So be prepared to have an in-class exercise in any class. The in-class exercises will be performed in groups of 2. It will be an open book, open notes exercise. But the only restriction is, although it seems very convenient to you to work in groups of 2, but the only restriction is if your partner is absent without prior information to me or without prior knowledge, the whole group will be counted absent. That means even the guy who is present will not be graded, will not be given any marks. No makeup in-class exercises will be made unless I had already been informed prior to the class, and even in that case, you must have an approved leave application in place signed by dean and your supervisor or faculty advisor, batch advisor. Number 3, the attendance policy. Of course, we'll be following the institute's attendance policy, which states that 80% attendance is necessary to sit in the final exams, and I'll strictly follow it. That means that you will need to be at least present in 36 out of 45 classes to sit in the final exam. The attendance will be taken at the start of each class, and there will be no attendance after 10 minutes of the start of the class. If you are later than 10 minutes, please do not insist with TA that your attendance be marked. It will not be marked. I have strictly told the TA not to mark your attendance. Be punctual and regular so as to avoid missing any important class discussion or surprise in class exercises, of course. So that's a job that needs to be done at your end. So here is the tentative course outline that I'll be following during the course of CS352 during the next 15 weeks. First, we'll start with this lecture, which is basically the course instruction and introduction. I'll be introducing the different policies. I'll be introducing the course staff. I'll be introducing course textbook. I'll be introducing course information, and finally evaluation policies and rules, which is something that I've kind of done during this course, during this lecture already. Then in the next lecture, we'll be talking about soft computing and artificial intelligence, the relationship between them basically. So it will be what is soft computing, what is AI, then a bit of history of soft computing, related topics in AI. Of course, AI is a very old field, and similarly the topics in soft computing are also very old, but the name soft computing is kind of relatively new. Then we'll be talking about applications of AI in real life, and finally the different expectations from this course that you people might be having. Then in the third lecture, we'll be talking about the state space, and specifically the focus in this regard would be on the uninformed search techniques and algorithms. We'll be talking about reflex agents and planning agents, what's the difference between them and how they work, the simplest ones. Then we'll start with what is state space and how to represent it, and what are the search problems that are related to the state space search. Then we'll talk about what's the difference between search trees and search graphs, and how they're both used in programming and in particular problems. And finally, we'll talk about the different tree search algorithms where or strategies where the focus would be on which algorithm is better and what are different properties of these algorithms. We'll be definitely talking about depth first search, DFS, breadth first search, BFS, and uniform cost search, UCS approaches. That will be all for lecture 3. In lecture 4, we'll be talking about heuristics and informed searches. First, I'll be introducing what a heuristic is and what different characteristics of heuristics are. Then we'll specifically look at a search algorithm called greedy best first search, which is basically a greedy approach. Then I'll talk about A star search algorithm, and the focus is going to be on the technique and algorithm itself and why it's useful, etc., and its applications. Then we'll move on to optimization problems and search techniques and local search algorithms, where the first topic that we'll discuss in this particular lecture would be on local search algorithms and optimization problems, what they are and what's the specific characteristic that differentiates these type of problems from informed search and uninformed search algorithms. Then we'll specifically study 3 algorithms in this class. The first one is going to be hill climbing algorithm. And the second one will also look at different drawbacks and the advantages of each of these algorithms. Then in the next lecture, in the next topic, we'll be starting with simulated annealing algorithm, and finally we'll discuss genetic algorithms. So in all these problems, the main thing would be how to formulate the problem and how to apply these algorithms. The mechanical steps and the concepts behind these algorithms will be discussed in detail. That will be all for mid probably, although until mid I think we'll also be discussing, or we have already discussed the topic of Markov chain Monte Carlo algorithms, Markov chains, I think. The next topic would be games and adversarial search techniques and algorithms. So in this particular topic, I'll be introducing what games are and what does searching in games really mean, how to formulate problems of games. Then we'll see a specific algorithm that is applied in adversarial search techniques, problems, which is called minimax algorithm. Then we'll see that since minimax algorithm has some specific problems with time complexity, it is exponential in nature, so we'll have to improve the time complexity, and for that we'll see that although the time complexity itself cannot be improved, but at least the number of steps can be significantly decreased if we get the good ordering on the game tree. And in that scenario, an pruning algorithm called alpha beta pruning can be used. And then finally, a very interesting topic on the current state of man versus machine in games. So what is the current state of different games in terms of which game is now owned by a machine, by a computer, and which games are still not conquered by a computer, and a human brain is better in that particular game. And you'll notice that probably in almost all games now, and you'll be surprised to know that in almost all board games, on all deterministic games at least, it's the computers who are ruling, and it's no surprise now. And with that, we'll move on to the next lecture 7, which is going to be probabilistic search techniques and models. In this particular topic, I'll just introduce you first to the basic concepts of probability. Specifically, the focus would be on conditional probability and dependence. What do these two terms mean, and what do they indicate? Then we'll move on to Markov chains. Markov chains will then be followed by hidden Markov models, and then I'll be talking about two specific algorithms that are very necessary in HMMs, hidden Markov models, and are basically the backbone of the whole calculation in HMMs. The first algorithm is called the forward-backward algorithm, and then I'll be basically discussing about Viterbi algorithm as well. So these two are two dynamic programming algorithms that we'll discuss in a lot more detail in this particular lecture. Then we'll move on to the ant colony optimization algorithm, which is another kind of optimization algorithm, and I'll start by first introducing the ant colony optimization problem, and we'll also discuss the biological inspiration for this particular algorithm. Then I'll discuss the algorithm itself and the salient features of algorithm, and then we'll apply it specifically to traveling salesman problem, which will then be followed by other applications in various real life problems. Then we'll also discuss another optimization algorithm called artificial bee colony. Again, this is biologically inspired from bees, and I'll introduce a problem which will again be followed by the algorithm itself, and then we'll also apply this to traveling salesman problem, and finally we'll see the different other applications of ABC or artificial bee colony algorithm. So far, the things that we have studied are kind of hard coded and are hard in nature. That is like each move will result in the same result all the time. But here we may have a problem where we'll require not so strict boundaries, and that is where fuzzy logic comes in. We'll also discuss fuzzy logic. We'll discuss the introduction to fuzzy logic, then the motivation for using fuzzy logic with the examples. Then I'll definitely differentiate between fuzzy versus crisp sets, and it will be followed by a specific application where a room cooler will be taken as an example, and we'll see how fuzzy logic will be applied. And finally, we'll see some other real life applications in control systems, specifically where the theory of fuzzy logic becomes very handy. So these are the main course contents that we'll be seeing, and this is the course outline, but this is tentative and it is bound to change. And at the moment, I'm hoping that I'll be able to cover all these 10 topics in good enough detail by the end of 15 weeks. And I really hope that you guys are able to cope up with the content and with the detail that I'm going to give to you. So after having gone through almost all of the major salient features of the course, I need to talk to you about some of the rules and regulations of my class. And you need to follow all of these in my class, otherwise there'll be severe repercussions for you guys. So you need to be absolutely careful about these, and you don't need reminders from me at any time. I'm not going to give you any more reminders, but I really hope that this one time is going to be good enough for you guys. First of all, the attendance rule. Do not mark your friend present whatsoever. If he is absent, or you know that he is not going to come to the class, or being late, will be late in the class, regardless, you should not mark your friend present. Proxy will not be tolerated at any cost, and 3 attendances of the student or you, whoever, if you're caught, of course, otherwise the student himself who puts the proxy, his 3 attendances will be deducted straight away. So just for 1 attendance, please do not waste your 3 attendances. Second, discipline in the class. How do I want to maintain them? If the class has started, please use the back door. The front door will be locked at the start of each class. Any disturbance in this class from inside and from outside will not be tolerated. That means that you should not be kicking out doors or banging, hitting, or trying anything from the front door. If it is locked, please do not even try it. Sleeping as well as using mobile phones is allowed in the class, but creating any kind of disturbance will not be tolerated, as I said before. Of course, if you can sleep during my lectures, you're allowed to sleep, but please do not snore. Number 3, cheating. So cheating of any type in my class will not be tolerated. Simple as that, full stop. What does cheating include? Cheating includes sharing your solution, your idea, or your work with any other student. There is going to be severe negative marking. Although, of course, before marking, first you'll be given 0 in that particular assignment, and then you'll have severe negative marking. And by severe negative marking, what I mean is a minimum of at least 10% negative marks. So if your course has a total of 100% marks, you'll get minus 10% in that particular category without getting any marks for your assignments. So you start for or your task. And if you're caught cheating in the final exams, you will go for a straight F in the course. So my recommendation to you is, please do not cheat at all. Try to come up with your own original work. You may discuss, as I've already said before, but basically the final solution and the idea must be completely yours. Okay, then we come to the deadlines and marking rules. Marking is going to be performed by the TA for the in-class exercises and by the instructor for the midterm, final and assignments. The TA shall mark the in-class exercises within 5 days and return them to you. Then you have to come up with any corrections or any issues within the next 5 days. If you have any question about the marking of in-class exercises, please talk to the TA. And remember, you have to come up to the TA within the 5 days. If you come to her after more than 5 days, there will be no change in your grade whatsoever. You will get the same marks. The marks are going to be fixed. Please don't come to us later on saying that you want to get your assignment rechecked or in-class exercise rechecked. That is not going to happen. With that, I think since the rules are clear to you, we'll then move on to the next lecture. That's all from my side. I really hope that this was a good enough introduction and you're really motivated to study this course. Thank you and goodbye. Thanks for listening, guys. Hope you'll enjoy this course as much as I'll enjoy teaching it. And best wishes for you. Hope to see you in the next lecture.